In maximum, I'm on page 126. So for minimum and maximum, we just need to understand the following. When we did a cubic function, we had a local minimum or local maximum. So it's basically the same thing. So what we did was, okay, if it was like this, it has a minimum, like this, it has no maximum and then minimum. So here it has a max. Here it has a minimum. Now, how we found them is like, as you can see, the minimum and the maximum are basically the turning points. Now, how did we find the turning points? We just had to find the first derivative with the cubic. To find the turning points, you find the first derivative and you equate it to 0. Same thing. So every single time they say find the minimum or maximum, both of them, either minimum or maximum, you just do one thing. You just find the first derivative of that function they gave you and then equate it to 0 and then solve for x or for whatever variable makes up that equation. As easy as that. For every single situation, when they say minimum or maximum, just find the first derivative of that equation and then you find it, as this is implying. So here, as you can see, for minimum, here as you can see, also for maximum, still the first derivative equated to 0. And it doesn't matter which one they asked, for both of them, the same thing. Okay, let's look at this one. So this one is asking us, consider again the scenario in example 34, the previous example. The volume of water in the tank, again, you're still having this formula. Now, question. Can read the question, the statement. After how many hours does the volume of the water start decreasing? Now, for you to understand these things, you just need to understand that this is a parabola. This is a parabola. If you look at the first term, it's negative. That means we have a frowny. That means we have something like this. Now, to know where is it decreasing, you can see here it's increasing. Up until the turning point, it was increasing, going up, and then it starts going down after the turning point. So it's decreasing after the turning point. So basically, you just need to find the turning point, and then that's it. So you can remember how we find the turning point? Using the cubic, the same way. You can find the first derivative, equate it to 0, and then solve for t, you'll find the turning point. It'll give you the turning point. Let's just use this. So first derivative equated to 0. So that means the t here at the turning point is 12. So it'll start decreasing after t equals to 12 hours. So yeah, you also have to look at them as parabolas. And then the second question, what is the maximum volume of the water tank? Like we said, you just first the first derivative, and then equate it to 0, and then you'll find the time. Now, here they want the maximum. So with a parabola like this one, again, you have it like this. So in this case, let's say it's like something like this. Now, we found the t here, which is 12. Now, the question is asking, what's the maximum volume? They just want the y-coordinate of the turning point. So you just need to take that 12, put it into the equation, the original equation, and then you'll be sorted. So the maximum volume of water in the tank is 150 liters. I'll stop there.